Welcome to Math 098, Section 3.2, where we are doing linear inequalities and solving problems. And the first thing I want to make sure that you're familiar with is interval notation. I know at some point in Algebra 2 that you learned this, but it's a different way of writing all real numbers, and because what we'll be doing is we'll be solving problems and our answers will be in an interval, and you're probably used to writing either like this or in set builder notation. Tends to confuse students, but I want to point out that this is meant to write less. If you notice, interval notation is a lot less writing than what you've probably written in the past. So the first thing to remember is we use parentheses anytime we use infinity. And the next thing I want to point out is interval notation always goes from least to greatest. So think of the smallest possible number, and again you want to think of the negative infinity as the smallest, you can't think of a smaller number, to the greatest. So we always write the smallest number furthest to the left. So if you want to say between -2 and 3, you want to write -2 first and then end at 3. We also use parentheses when it's not equal to. So this might be something you already know. So notice that it's x is bigger than -2, but we're not including -2. And then 3, we're ending right there. So let me change my highlighter to point out the brackets. We use a bracket. I don't know if you can even see that. Let me choose a different highlighter. There we go. A bracket here and here to say we are including -2 and 3. Notice I'm still going least to greatest. Now you do a bracket, and then you can see how we do two different ones where you can have one's a bracket, one's not a bracket, or I should say one's a bracket, one's a parenthesis. So we write it like this. Also notice that we still have infinities. If we want a number that's smaller than -2, and you might be stumped, like, well, how do you write a number that's smaller than -2? Well, you just say, well, the least is negative infinity, so we want all the numbers from negative infinity until you get to -2, and again a parenthesis if you do not want to include it. So I've seen students really struggle with writing less than or just greater than because they don't realize that you have a left bound and a right bound. Well, if it's unbounded on the right side or unbounded on the left side, you can use the infinity symbol. Now I also put set builder notation on here because I believe in this textbook, if you check your answers in the back, I think they write in set builder notation, but they might actually write in interval now that I'm thinking about it. But sometimes in the back of the book they write it like this, and students always get confused, like, what does this x bar mean? That's written as x, excuse me, I should write it out. It's saying that we want values of x satisfying the following condition. Now, nobody wants to write that over and over again. And obviously we have the following condition is written out. -2 is less than x is less than 3. So what they did is, as math people are lazy, they just shorten this. X bar means this, and that is accepted. So if at any point you see this, do not be scared. If you forget it, I can forgive you. A future math teacher might not, though. So just remember that moving forward. So what we're going to do is, I just said it might not even show up, but then I have it on the very first example. You can sort of ignore this x bar, but it's saying all values of x satisfying that x is bigger than or equal to 2. So on the number line, that's what we're doing, I like to see 0 somewhere on your page, and then positive 2 is to the right of that. I am filling it in because of the bar underneath. We want to include that, and values bigger than 2 are to the right of x equals 2. That's it. That's all I need to see. So again, you can ignore this first piece. It's just saying all values of x satisfying that x is less than -1. Again, I like to see 0 because you're showing me that you understand that negative numbers are to the left of 0, whereas positive numbers are to the right. So we want an open because we're missing the equal to. So we're telling the reader that, hey, we do not want to include x equals -1 and less than is pointed to the left. And then the last problem I have for you is we have it written this way. Again, I like to see 0, and it'd be nice if you showed me what you're counting by. So we want about 0.5, but we're not including 0.5 because there's no bar, all the way until we get to 3, and we want to include 3, so fill in that circle. It's a closed circle. As I'm going back and rereading the directions, I missed this part where it says write in interval notation. I think it actually helps to have the graph because then you can look at this and say, oh, well, the first time that I put anything down was at 2. So I'm going to write 2 first. And I have this arrowhead going infinitely to the right, so I'm going to have infinity. Now there's 2 other things you need. First of all, infinity always uses a parenthesis. And because I filled in this dot, or because it's equal to, we need a bracket. So let's look at the next problem. The first time that the function is defined, well, you see how we have this arrowhead first. And I've actually taught it this way too. If you see the arrowhead to the left, you have to write negative infinity. And then it stops once I get to this value of -1. And again, from the first example, you can see that we have infinity, so it's a parenthesis there, and at -1 because it's an open circle or because there's no equal to, that is a parenthesis there. And then this one, well, there's no arrows, okay, for the function that we're talking about. So there's no infinity, but the first time it's defined is 0.5, and then it stops being defined once I get to 3. Open at 0.5 means a parenthesis, and closed at 3 means a bracket. So that might help some of you be able to graph and write in interval notation. So I think that'll help you, because as you try to solve these future problems, what they're asking you to do is to get x by itself. So subtract that 5 over. So we're looking at x is greater than 4. So it might help you to graph on the number line. So again, I like to see 0. So 0 is to the left of all positive numbers. So 4 is over here. Open circle because it's not equal to. Greater than means to the right. And that might help you realize that the solutions that we want, as an open at 4, so a parenthesis 4, and then an arrowhead to the right tells me we're going infinitely to the right, and that has to have a parenthesis. There's your answer. Again, feel free to pause at any point or go back and rewatch anything. That's the beauty of these videos. So here's another problem, and maybe I should have mentioned it, that you always treat these inequalities as if they're equal signs. Again, I'm confident you're familiar from Algebra 2 for this. So what I would do to solve this is subtract 2x to the left side. I thought I'd change colors, but that's okay. There it is. So I'm left with 1x plus 1 is less than or equal to -3. And then subtract 1 over. I'm looking at x is less than or equal to -4. All right, but that's not good enough. We have to write in interval notation, and we have to graph it. So please write 0 somewhere on your page to show me that you understand that -4, 1, 2, 3, is over here. I need to fill it in, and less than is indicating to the left. So in interval notation, I'm going to start at -infinity because my arrow to the left, and I stop once I get to -4 with a bracket because it equals. I don't like that circle. And I need to apologize for the next one because sometimes they don't show up as fractions. This was intended to be 2/5 x is greater than or equal to 4/15. So I know some students really prefer multiplying by the reciprocal or dividing by in order to solve for x, but I'm a big fan of multiplying by the reciprocal to get x by itself. So I'm going to multiply both sides by 5/2. And the reason why I'm a big fan of that is because you can see the 5's cancel and the 2's cancel, and you're just left with x. Now the other reason why I really like how it's set up, and you might not learn it this way, so let me point out that some students, you just need to write it out. 4 times 5 is 20 because you multiply straight across, and 15 times 2 is 30, and then you could divide both those by 10 to get that the correct reduced answer is 2/3. I'm a big fan of another method. Now stick with me, because I look at this and I say, okay, well 5 goes into 15 3 times. Because 15 is bigger, I write the 3 on bottom. And 2 goes into 4 twice. And because 4 is bigger than 2, 2 goes in the top. So my answer is just 2/3. I don't care how you solve it. Okay, but we still need a graph. Again, please show me that you understand that 0, and I'm going to count by 1/3 to recognize that right here is my closed dot, greater than is to the right. So we're going from 2/3 to infinity. All right. And then I think this will be the last one I explain for this part of the video. I think it's important to realize why we have a certain rule in math. So I'm going to scroll down and talk about this certain rule. Is if I were to ask you to compare, I don't know, 6 to 8, I'm confident that you all would say, oh, okay, well 6 is smaller than 8. Well then, what if I said, okay, we'll double each of those numbers. So multiply by 2, multiply by 2. Okay, so we're looking at 12 and 16. Is it still true that 12 is smaller than 16? You would say yes. Yes, that is true. But what if I looked at 6 and 8, but then thought about, okay, so it's the same comparison, multiplied by -2. Multiplied by -2. Well, now we're looking at -12 and -16. Now, is it still true that this less than sign stays the same? No. And this is why when you multiply or divide by a negative, because I could have done this as well with division, but I'm running low on time and I want to be done with this and move on to the next example. By a negative, you have to flip the inequality. You may know that rule, but maybe you don't even know why it's true. But this is why. And you could try this with any number you want, because if you start with it, being a greater than and you multiply by a negative, you would still have to flip that inequality. Now, I bring that to your attention because lo and behold, we are dividing by a negative. So we're left with x. I believe that's -3, but then it flips to be greater than. So on your number line, no, that's not -3. That's -4. There you go. Because 4 times 4 is 16, 2 times 4 is 8, carry the 1. Anyway, 1, 2, 3, 4, open circle to the right because it's greater than, and then -4 to infinity. There we go. So pause the video, and I will see you in the next one to finish up these notes.